Hello everyone. For this tutorial video, I'd like to go over elasticity versus rigidity, aka how different solid objects deform when you apply a force to them. As you may already know, every solid material is different, i.e. made out of different types of chemical compositions, and so these determine mechanical properties of the object as well. Although thinking about it on a microscopic level like that can get so complicated that we generally do not, and instead resort to trial and error tests of different materials to determine how sensitive an object is to a force, i.e. how greatly it will change its length, called deformation, in response to a force of the same magnitude. Mathematically, the elasticity versus rigidity of a material can be stated as force equals rigidity, represented with a lowercase k, times change in length. This statement is called Hooke's law, after the English physicist Robert Hooke, who first figured it out for mechanical springs. Although we know now it applies to deformation of any object, not just the compression of a spring. However, there are other factors at play as well, such as the cross-sectional area of the object as experiencing the force. In particular, a thicker object, i.e. an object with a greater cross-sectional area, will have a greater resistance to changes in its shape than an object with a smaller or thinner cross-sectional area. The next most common type of deformation is called shearing an object, which has factors similar to rigidity versus stiffness when you push an object directly. But shearing refers to pushing on an object perpendicular to its length to create a sort of parallelogram shape, rather than directly parallel to its length. For example, by twisting on an object. Just like pushing on an object parallel to its length can break it, pushing on an object perpendicular to its length can rip it as well. And in general, many objects are more sensitive to ripping in the perpendicular direction rather than the parallel one. The final type of deformation is known as bulk modulus, which is the description of the tendency of an object to resist changes in its volume from forces pressing in all directions. In general, thicker materials will have greater resistance to pressure from all directions, similar to how it is true for forces pressing on an object, aka parallel to it, and forces perpendicular to it. Now that I've gone over all of the basics of linear motion, including descriptions of what it is and why it works, I can move on to teaching the basics of rotational motion, starting with constant velocity rotational motion, also called uniform circular motion, as it has a uniform velocity throughout the whole rotation. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.